right, class. So what we do know is that, look at this, and then I explain the chapter we are doing right now. Can you all see? Students, can you all see? Hello? Can you hear me nicely? Okay, good. Let's push. So we know that our chemistry has 12 topics. Okay? Our Cambridge IGCSE chemistry. Matter of fact, let me see if I can show you. Let me do it like this. Okay. So that we talk quickly. I quickly show you what I want to say. Look at what we are looking at today. Right, look at this. Look at this, everybody. Our chem is 12 topics, right? We've done some nice ones, big ones. We still have a long way to go. But it's fine. This is not a hard subject. We can lock in and do it in no time at all. So everybody look closely so you understand. Right. What you need to know is you need to know 4, 5, 6. We've done 7. You need to know 4, 5, 6, 8, 9, 10, 11, 12. ASAP. You need to know these as soon as possible. And 3 as well, because it comes every time. Now, here what I want to do is, I know that 5, 6, and 11 go together. Okay? Organic chemistry, for you to really enjoy doing questions for organic chemistry, you need to be good at 5 and 6. I know that. And I'm going to brush you up on those. So you're good. So you actually enjoy doing. Because there is a part of organic chemistry which is not from chapter 11. They'll give you methane or whatever they'll give you, which is from organic chemistry. But then they will actually ask questions to do with this. Rate of reaction or bonds or something like that. So that will not be an organic chemistry question. Watch out. You're not going to let me down. Organic chemistry, you know that this is an organic chemistry question. When they ask you for reactions or isomers or to draw compounds or what, if they're asking for rate of reaction, whatever, even if they give you methane, so what? Okay, they've given you methane, but they're not asking organic chemistry questions. They are asking rate of reaction, so it will be chapter 5. I'll need you to be good at that. What we're looking at right now is not that, okay? I'm going to look at that and join them together for you. I've already said it. What I want to look at today is chemistry of the environment. I want to quickly touch on this chapter. We do it as much as we can. We do it as fast as we can. We master all the things and then we can move on. If you go to this chapter 10, the chemistry of the environment, and you see what the syllabus expects you to know, it's 2 sections. Let me go to it. Okay, it expects you to know 2 sections. Number 1 is water, then number 2 is air. Where is air? Number 2 is air. Okay, so water and fertilizers, we'll talk about it together, and then you talk about air and climate, and you're done. So basically, that is what we normally say. You need to know about water, and you need to know about air and climate, and you're done. Did you see that? Water. You need to know about water, Can you see this? Then after knowing about water, you need to know about air. Okay, you can talk about also fertilizers, which is this small section, and then you have this whole section on air. You need to know about air and what are the pollutants, and then how do we get rid of them. Are we together? Have you seen the section that we're going through? Students, have you seen the section we're going through? Remember, in 3 months' time, we should be done with all this. There should be no lesson where Mr. Clarify says, hey guys, let's quickly just recover. Oh, we don't have time. The exam is coming. Let's quickly. We won't do that. We'll be done. We are doing it now. Now is the time where I'm saying, hey guys, come. Let's quickly do chapter 10. Hey guys, come. Let's do 5 and 6. Let's see the questions. Hey guys, come. Then we are not going to do anything to do with that. Are we agreeing? Everybody, are we all on the same page? Why are you quiet? Talk to me. Pardon? Say it again. What did you say? Okay, good. You are hearing me. Can you hear me nicely? Your volume is low. Let's see. Seth, can you hear me? It's been a long time since I heard your voice. All right, good. So let's quickly go through. These are the times we're going through all these chapters as fast as we can. So everybody write chapter 10. We have no more time to waste. Let's go and get started. Everybody knows what chapter we're doing. We're going to get started. This is our day 1, chapter 10. Let me say back. Let me try to write in white. Make sure everything is being recorded. Good. All right, let's start. So we said we have 12 topics, and we are looking at topic number 10. We're looking at topic number 10, which is chemistry of the environment. We're looking at topic number 10, which is chemistry of the environment. Write with me. Chemistry of the environment. Chemistry of the environment. Everybody knows already. It's just we need to talk about water and we need to talk about air. So let's talk about water first. Okay. Then we'll talk about air. So part 1. Water and water pollution. Water and water pollution. Water and water pollution. This chapter is really answering one big question. The chapter of water and water pollution answers one big question. And that one big question is, where does our water come from? What can it be found in? Where can we find water? And Okay, let me say, what can be found in? How do we make it safe? And how can human activities, how can human activities affect water quality? Tell us, how do human activities affect water quality? Where does our water come from? What can it be found in? How do we make it safe? And how do human activities affect water quality? So let's quickly write on that. This is what we're covering, and we move. Okay. Let's put the map of this part, so it's of this section, okay? This section, okay, or you can say section 1 has 4 parts. Which is 1, the chemical test for water. The chemical test for water. Number 2, substances in natural water. Okay, the chemical test for water, substances you find in natural water, water treatment, and finally, fertilizers. Okay, the syllabus makes it as its own section, but we can cover it in no time. Chemical test for water will be so that we find out how we can identify water. The chemical test for water. How do we know this is water? What if it's an acid? What if it's a colorless acid and you think it's water? How do you know it's water? And the substances that are in natural water. When we say natural water, we mean rivers, lakes. Okay, in natural water, we mean rivers, lakes, underground water, or just say groundwater. What do we find in these? What do we find? Then water treatment is how do we make water safe to drink? Water treatment, it's how do we make water safe to drink? So it's not too much. And then fertilizers, these are, okay, nutrients needed for boosting plant growth, okay? We'll talk about them as well. Are you ready? Chemical test for water is like, okay, how to identify water. Okay, so let's start. Chemical test for water. Let's start with that. Okay. So 1. The two chemical tests for water. You must know them. The 2 chemical tests for water. You must know the 2 chemical tests for water. So I want you to write, to say this. Write with us to say, there are 2 tests for water. Okay? And you can say, these answer a very common exam question. The two test water help you to answer a very common exam question, which says, how do we test for water? When you get this question, how do we test for water? You shouldn't panic. I need you to answer it. How do we test for water? I don't want you to panic. I need you to answer it. Are we ready? Are we together? Hello? If you answer how do you test for water, I need you to be able to quickly answer it. Right, let's put the test for water. It's easy. Let me see. It seems like the YouTube video stopped. What happened now? Let me fix. Sorry guys. Let me fix it. Okay, good. Let's put the test number 1. Test 1 for water is using anhydrous cobalt 2 chloride. Using anhydrous cobalt 2 chloride. This is the first test for water. Using anhydrous cobalt 2 chloride. So, anhydrous cobalt 2 chloride is usually used to test for water as cobalt chloride paper. Okay? You can use cobalt chloride paper. What happens? Okay? So what you must know is that it goes through color changes when it becomes hydrated. If you add water, once you add water to cobalt 2 chloride, its color will change. Anhydrous cobalt 2 chloride, let's put. Okay, I need to put colors that I'm sure everybody can see. Okay. Anhydrous cobalt 2 chloride. You can just say cobalt chloride is blue. But hydrated cobalt chloride, you can say cobalt 2 chloride, is pinker. It becomes pink. So you can say, if water is present, anhydrous cobalt 2 chloride turns from blue to pink to confirm that it is water. So it does this with water. Okay? So here's what we say. We say anhydrous cobalt 2 chloride is blue before and pink after. It is blue before water and pink after water. Blue before, pink after. Are we together? This is the first test for water. Right. Test number 2 for water. Test 2 for water is anhydrous copper 2 sulfate. This one, instead of starting blue, it turns blue. Cobalt 2 chloride starts as blue and turns pink. So you should say, right here to say now, this is another very common test for water. Test for water. When water is added, anhydrous means with no water. So it was anhydrous before water was added. Now you add what you think is water. You add something you don't know, but you think that thing is water, and then you see what goes on. So when water is added, what should happen to anhydrous? Anhydrous copper 2 sulfate goes through color changes. When water is added, anhydrous copper 2 sulfate should go through color changes. When water has been added, it should go through color changes. Okay? What are the color changes? Anhydrous copper 2 sulfate. Okay? I'll teach you something about transition metals, that they are usually 2, 2, 2. Iron 2, copper 2, cobalt 2. These transition metals, they're usually 2. Anhydrous copper 2 sulfate is white, the color. Hydrated, which means when you add water, hydrated copper 2 sulfate is blue. So if water is present, then anhydrous copper 2 sulfate turns from white to blue. If water is present, anhydrous copper 2 sulfate turns from white to blue. So it was white before, and then it becomes blue after. White before, blue after. Are we together? Are we together? Let's look at the next thing. We've done test for water. Let's talk about purity of water. That's the next thing you gotta know. Purity of water. Okay? In the next 5 minutes. Just what so we're done. Pure water has a fixed melting point, which is 0 degrees Celsius, and a fixed boiling point, which is 100 degrees Celsius. Okay? So what you should just know is whenever we say something is pure, that means the melting point, any pure substance, you should know it from today going on. Anything that is pure has a melting point that you know and a boiling point that you know. Once you start adding impurities, these begin to change. Once you start to add impurities, things that are not water, you start adding them to water, salts or whatever, then you start to see your melting point change. So we can write here to say pure water melts at 0 degrees Celsius and boils at 100 degrees Celsius. You are done. Don't worry. Don't worry about anything. Don't worry about anything. Don't look at anything else. Just check the melting point and the boiling point. If it's these ones, then the water is pure. So, to test for purity, measure 1, melting point, and 2, boiling point. Okay? To test for purity, just measure the melting point and the boiling point. Why? You can write it, say, pure substances have a fixed, known melting point and boiling point. Pure substances have a fixed and known melting point and boiling point. If the values for melting point, I keep saying this, and boiling point are exactly 0 degrees Celsius and 100 degrees Celsius, then the water, you say respectively, then the water is pure. If you get these values, then the water is pure. Okay? Now, what's the time? I give you one more statement. I give you one more thing. One more statement. Effect of impurities on water. One, you say, impurities increase the boiling point. If you want to know when water is impure, If it boils above 100 degrees, then that water is not clean, it's impure. It's not pure, it's impure. That means it has other things that are not water inside it. That water has other things. If it's just water with nothing else, then it should be exactly at 100. So impurities increase boiling point. So you can already know that impure water boils above 100 degrees. Okay? To boil with those impurities, it will be above 100 degrees. Last sentence. Last sentence. Are you seeing this? Last sentence now. Okay? Because of time. Last sentence. Impurities, on the other hand, lower the melting point. Impurities lower the melting point. So therefore, what do we know? We know that impure water melts below 0 degrees Celsius. Before it's 0, you see it being liquid. Oh, that's not pure water. Are we together? Are we together? We'll continue this in the next chem lesson. We'll continue. We are not done. We have work to do, so we'll quickly continue with our work on water, and we'll continue with our work in bio. We'll continue with our very, very strong work, pushing excretion to finish it, pushing this chapter to finish it. You keep your resources. So I'm going to give you links to submit, and I'm going to be calling everybody to make sure you all submit, because I need to make sure everybody has this, okay? Because if I make sure everybody has this, then we're going to have a softer September. Our September is going to be much nicer, much nicer, much nicer. We do not do things last minute. That's not going to happen. I'm not going to allow you. I'm not going to let you do that. I'm not going to let you stress last minute. So we're going to push. Thank you so much for your attention to this matter. Goodbye. Good night, everybody. We'll meet tomorrow. I'll give you the updates. Okay? I'll make sure you have, if you are not on the website, just communicate with me. But goodbye and good night. We'll meet tomorrow. We'll push a lot of the subjects, and by the time we get to September, we'll be all smiles. No more stressing. So we'll continue with water tomorrow. We'll continue with excretion in biology tomorrow, and the other subjects. Goodbye.